Good afternoon, everyone. Myself, Mrs. Rane, from ENTC Department of RSCOE. Today, we will be discussing how to start the Matlab, how to start with the Matlab. In the Google window, you can type here Matlab online.
Excuse me, ma'am.
Yes, so in the Google, type Matlab online, everyone. Then this link, Matlab online, Matlab and Simulink, here you have to click. So all are up to this, all have getting this window. Here we are observing the start using Matlab online option. We have to click on that. Without installing this Matlab software on your machine also, we can access it. Okay. Then we will.
When I put,
they can use GNU Octave option because single line instructions today we are going to discuss. So they can use GNU Octave option also. In Google search, you have to type GNU.
1 second. GNU.
GNU Octave. OCTAVE. GNU space OCTAVE.
Okay.
So it is also working as like Matlab only. Line by line.
Shall I download it?
No, no need to download directly. Also, we can run the instructions on that.
Okay.
Just I will.
Yeah, GNU Octave. There is two options are there. Download.
This type of the window you will get over there. Octave online, GNU online. Yeah. So in this session now we are going to discuss these topics. First of all, some introduction I'll give you about the Matlab. Then desktop basics we will discuss, matrices and arrays, array indexing, workspace variables, then plots, how to show the plots in Matlab, programming and scripts, help and documentation. These points we are going to discuss today. So the Matlab is a language which supports vectors and matrices operations that are fundamental to engineering and scientific problems. So from where that Matlab word comes, it stands for Matrices Laboratory. It is a high performance language for technical computing. It integrates computation as well as visualization of your results and programming. Typically, this Matlab is used in algorithm development, modeling, simulation, prototyping, data analysis, exploration and visualization, scientific and engineering graphics, application developments. Now, when we are starting with the Matlab, that time 4 type of windows we are observing. I think for them, those who have possible, they have opened this online Matlab. There, they will observe these 4 type of the different windows. First one is Matlab command window. Second is current directory window. Third is workspace window and the editor window. All are getting this window when they are opening the online Matlab. So 4 windows, whatever just now I list out of that, this current directory, here we can see the current directory. This portion is a current directory. Workspace is here. Editor part is here. And the command window is this part. Here we can see the command prompt. So single line instructions, if we want to execute this command, we can type over here on this command prompt, right? If your program is containing number of lines sequentially, then it's not advisable to use the command prompt. In that case, we will use the editor window. If our code is containing more number of lines, we will use the editor window. Here we will type our code lines and then we can run it in the Matlab. Current directory will show you whatever are your previous files in that particular directory. Workspace area will give us the names of all the variables. Those are used in the session. Along with, we can see here the value also of this declared variables. For example, the variable k, it was used in my previous session. So that k is equal to 1 is the value for that variable. What is the size of that variable and what is the type of that variable? Means it is having a class of double or it is an integer or any other class. This detailed information about the variables is given in the workspace area. Okay, so these are the 4 sections. Shall I repeat once about these 4 sections? Very important to know about it basically. I repeat, when you are opening the Matlab, that time 4 type of the windows we are observing. First one is take this command window. Here we are observing the command prompt. Here we can type our single line instructions, and immediately when you are after entering the instruction, if you are enter over here, immediately we are getting the result displayed in the same window. But if our code is containing more number of lines, then we have to use this part, editor section. Because one line by line execution on command prompt will be a little bit difficult. So when our program is lengthy, we have to use the editor section only. Then the current folder. Here we are observing in which directory we are currently and what are the files stored in that directory. Workspace area is giving us the list of all the variables those are used in this session along with the values of all the variables. What is the value containing in that variable? What is the size of that variable? And what is the category? What is the class of that variable? Different classes means the type of variable. It is a double or it is long, it is integer or float, likewise. So that is about the basic windows we are observing when we are starting with our Matlab. Same window I have just displayed, but along with the code. Here you can see in this editor part, one small program is there containing 7 number of lines. Here figure window is also visible. When I'm executing this particular code, with respect to that, if any figure is getting generated, then that figure is getting displayed like this in the separate figure window. Okay, and in the command window you can see if any output values are generated, these values are getting
Excuse
displayed.
me, madam.
Yes.
मैडम इथं ना एडिटर विंडो जो आहे ना तो दिसत नाहीये तो हाऊ कमांड विंडो दिसतोय करंट पे दिसतंय वर्कस्पेस दिसतंय पण एडिटरचं जे आहे ना ते आमच्या याच्यामध्ये येत नाहीये.
सर एक काम करा, इथं न्यू सिम्बॉल दिसतंय जिथे मी पॉइंट करते बघा, न्यू वरती
न्यू
त्याच्यामध्ये हे ड्रॉप डाऊन करा, स्क्रिप्ट म्हणा तिथे
न्यू का येस
आलं का ते एडिटर विंडो आले
आले
येस ठीक आहे. So in the command prompt, if any numerical results are generated, these are getting displayed in the command window. Here is a figure window and here is your editor window where you have typed your code. And whatever the variables I have used in that particular program, you can see num, den, z, pk, all these variables are visible in the workspace area. Okay, clear? Now can we proceed further? Okay. So just short introduction I have given about each window. Command window. Here we are typing the instructions, right? So to communicate with Matlab program, use Matlab command window. Matlab display the prompt like this, command prompt, which is indicating that now your software is ready to receive the instructions. When at the initial stage, when it is starting, that time this command prompt will not be visible. After 2-3 seconds, it will be visible and indicating that now you can type the instructions over there on the command prompt. That is about command window. Next, current directory window. It is much like a file manager window. Means you have seen the list of files which I have already stored in that particular directory. So it is much like a file manager window used to access files. For example, .m file, list of .m files is available over there. So if I'm clicking on that, any of the file, that particular file is getting opened in the Matlab editor. All these things I will show you on demo also. Then workspace window. As I said, workspace window displays the detailed information of all the variables. So it displays the variables created in the command window. Workspace refers to the names and values of variables in use in the current work session. So it is giving you the list of names, all the values, all the types of these variables. Command history. All the previous instructions entered in the Matlab command window are visible here. You can double click and drag the command into the Matlab command window or Matlab editor. This also I will show you how to use the already typed instructions, how to reuse. Okay. First of all, we will complete this part. Okay. See here, initially you are not getting this editor window. Actually, it is hidden over here. Or you can do this. Click on the new script. You can adjust the length. You can adjust the height of editor as well as command window as per our requirement. Okay. Now here on the command prompt, I can give the instructions. Suppose example, a is equal to 5. I'm allotting the value 5 to variable a. And if I'm entering, I'm getting the corresponding result. Means 5 value is allotted to the variable a. Right. If I want to use the same instruction, you can see what I have done. Up arrow, you have to press the up arrow on the command prompt. All are there with me? Simple instruction we have typed on the command window. Corresponding output is displayed, right? Now, on the command prompt, press the up arrow. Previously typed instruction is available over there, right? So I can use it. I can modify over there if I want. I'm putting the semicolon at the end of the same instruction and execute it. For execution, I have to press enter. After typing the command, I have to press enter. Right? Same instruction, but here I am not getting any output because I have added the semicolon at the end of this particular instruction to suppress the output. Yes, just output is suppressed. It's there. Value of 5 is there in variable A. I can check it. What is in A? Type A on the command prompt and enter. A is having a value of 5. But as I have added semicolon at the end of instruction, the value was just suppressed. Right? So if many number of variables, if you are creating and if you want to hide the result of each and every to avoid the complexity, we can add the semicolon at the end of every instruction. Okay, this is the command window. Here is the editor window. I will show you one program here how to, whatever are your lines of command, you can type over here. This way. You can just check. In that editor window, you can give the instructions. You can enter more number of lines. And here at this adjacent to that, the line number is also getting displayed. Right now, you can see on the command prompt, I have used the variable A. So immediately that variable A is appearing in the workspace, right? Along with its value, A is having a value of 5. Its size, 1 by 1. See, it's a single number. So size is 1 by 1. Means 1 row, 1 column. Its class is double, right? So all the information regarding whatever the variables we are using, all are getting displayed over here. Here you can see in the current folder list of files and the file extension is .m. Every file is having the extension of .m. Matlab files are having this extension. Okay, clear about it? So you can see if I am pressing the up arrow at the command prompt, whatever the previously I have used instructions, all are visible. Out of that, anyone I can use just by clicking on that. That's it.
Yeah. All participants requested to execute this program. Yes, madam?
Yes, whatever I'm showing here, you try of your own, then you will be more confident about it. I'll give 2 minutes to complete this task, whatever we discussed just now. Everyone done with this part? This much? To check the instruction without semicolon, check the same instruction with semicolon, use some other variable, and you see, is it appearing in workspace or not? Your current directory will be blank at this stage because no any program you have saved over there. Okay, shall we proceed now?
Yes, madam. 1 minute. So people are putting the comment.
Okay. Chat box is not visible for me. Got it, sir? From chat box, any question which we are supposed to answer?
Right now, no questions. People are putting done. So I hope that everyone understand, or it is simple one. It is just starting or introduction of Matlab. So these are the very small things for you.
Okay, I think we can proceed now. Now we will see how to define an array, how to declare an array and matrix, right? So this I have put on the PPT also. On command prompt, we will give any variable, and that variable is equal to, in square bracket, we have to give the values which we want in particular vector. Suppose go to that online Matlab. On command prompt, you type that instruction. Give any other variable name. If you want, you can change the values. Enter. So this way we can create the vector. So as soon as we have used the variable h, we can see it is appearing in the workspace. Similarly, if I want to create a matrix, see the way how to give command to create a matrix. Any variable is equal to, in square bracket, we have to put the values, and at the end of every row, we have to put the semicolon here. After the values 1, 2, and 3, I have put the semicolon. And values we have to separate by space. Means 1 and 2, these two values are separated by space. At the end of every row, colon we have to add. Sorry, semicolon we have to add. And as I am not putting the semicolon at the end of instruction, I will be able to see the respective output. You can see here, matrix is generated with these values. In the first row, the values are 1, 2, and 3. As there is a semicolon, next row starts with the values 4, 5, 6. And third row with the values 7, 8, 10. Okay, done with this, everyone? I can check the size, whatever the variables I'm having, I can check the size, means whatever are the elements, what is the size of that? Suppose size of A. The size is displayed as 3 by 3, means 3 rows are there and 3 columns are there. If I'm checking the size of H, it is saying that 1 row is there and 4 columns are there. In the variable H, single row, 4 elements, 4 columns. So this way you can see the size of this variables also. Matrix vector generated, we can check the size. Completed everyone up to this? I can generate the vector with all values 0 also. And the variable name I have given as Z. Z is equal to zeros. Zeros is an inbuilt function. And in bracket, I am specifying the size, whatever we need. 5, first value represents the number of rows we need, and second value gives the number of columns we require. So we can see in the Z variable, 5 rows and 1 column with all the values equal to 0 is generated. Yes. You can check the size of the Z also immediately. On the command prompt, press up arrow. You will get the previously used instructions. Out of that, which one you want, you take it. By clicking on it, change the variable. Size of H. Sorry, size of Z we want to check. It is saying that 5 rows are there and 1 column is there. Okay. Yes. Shall we proceed? Now, some matrix operations we will discuss here, simple operations. If I want to check what is the value in variable A. A is a matrix that I have already defined. Now, if I want to add the value 10 in every element of that matrix A, simply I will put A plus 10, enter. We can see here every element of A variable A matrix is added with the 10 in that. 8 plus 10 becomes 18, 10 plus 10 becomes 20, this way. But since I have not given any variable to save the result, directly I have given the instruction A plus 10 instead of giving, for example, P equal to something. So that's why by default Matlab is taking the variable ANS. If you are not declaring the variable to store the result, that time ANS is a by default variable used to store your result. Okay. So instead of giving direct instruction, if I am using P equal to A plus 10, then the result is getting stored in variable P. Now, whatever are the values in matrix A, I can take the sign of every value also. You can check this instruction at your end on command prompt. Give any variable is equal to sign of already declared matrix. So, or A matrix, sign of each and every value is calculated and displayed here. We can take the transpose of matrix also. So for that, Again, I will check A value. And for taking A transpose, I have to give the command like this. We can see original matrix A is transpose over here. Similarly, we can use transpose function also for the same purpose. Transpose of A. Same result we are getting. So inbuilt function transpose is available in Matlab to take a transpose of matrix. Everyone check these things at your end. Okay. So shall we proceed? Better, sir. Hello.
Yes, yes, madam. Continue.
Okay. So this is about transpose. Here the matrix A, if you are giving the instruction like this, A, comma, to indicate the transpose operation, you will get the result like this. And parallelly, you can use the transpose inbuilt function also for the same purpose. If you want to cascade the values of matrices like this, vertically concatenation or horizontally concatenation, we can do that also. So we'll check it on Matlab. You can see another variable I have defined here, capital A. So in Matlab, the variables are case sensitive. Small a is different from capital A. So capital A is equal to, in square bracket, I am giving A, comma, A transpose. Check the result of it. This is the result. So this first three columns are indicating A matrix, and next to that, transpose of A is cascaded. Horizontal cascading. Check this also. Now, if I want to cascade vertically, then I have to put semicolon over there. To check this operation. Use any other variable. Suppose B, capital B is A semicolon A. So you can see first three rows are the A matrix, and again the same matrix is repeated here from row number 4 to 6. So this way we can cascade the matrices vertically or horizontally. Okay. If my audio is clear and you are observing the screen also, no any problem, right? Now, whatever the vector we have declared, suppose the 4 values I have given for that particular vector, then any value individually I can access, right? If I want to pick out this 65, then I have to give the location of that 65. That means row number 1 and column number 3, right? So you can see the instruction here given as from B, I want the value from first row and third column, that way. So on command prompt, already we have declared one vector, that is H. Check what is in H. And from that, if I want to access any of the value, you can give the location of that 1, 3, first row, third column. The value is 3. So this way, individual values also we can access. Same thing we can do with the matrix also. Already we are having a matrix A. Suppose I want to access this value directly, A from that third row and third column. So always first value is a row number and the second value is a column number. In the A matrix, another value I have given as second row and third column, which is this value 6. Now if I want to clear all the contents on command prompt, I can type CLC. If I want to clear everything, clear means I have to empty the space. I can type CLC. But you can see we have not cleared the variables. Just I have cleared the space. Okay. Shall we proceed now?
Yeah, madam.
Okay. So as well as like here we have accessed the individual values. The instructions can be given like this also. If I want the all the values of row number 3, if I want all the values of row number 3, I can give the row number, comma, since I'm trying to access all the columns, I have to give the colon over there. I'll show it here. A, second row, comma, colon. Means what? Second row and all the column values should be extracted. Yes. So we can see these values are extracted over here. Same way, if I want all the columns of any particular, sorry, all the rows of any particular column, that also we can do. Suppose 1 to 2, only 2 rows of second column or third column. Two 1 to 2. We can give any range here, comma, third column. Means from the third column, these two values will be extracted. You can see here. This is a B matrix, 1 to 2 row of the third column. That means these two values are extracted over here. Okay. Now, suppose in case of plotting function, means when you are plotting a graph, that time we have to create certain values for the, so for example, t variable. In that case, we can use the instruction like this. See, the syntax or the format for that instruction is starting value, step size, and the end value. For example, on command prompt, if I'm typing j variable, any variable j is equal to 1 colon 2 colon 10, means what? From 1 to 10, start value is 1, end value is 10. In that range, I have to generate the values, equally spaced values with the step size equal to 2, right? So corresponding result is also I have displayed over here. The range, the vector is starting with the start value 1. It is end value is 10, but since the step size 2 we have given, the values are generated like this. Second value will be 1 plus 2, that is 3. Next will be 3 plus 2, 5. So by the step size of 2, the values are generated in the range 1 to 10. So you can check this instruction also on the command prompt. You can check what happens if the step size is different, if the range is different. We can experiment over there. Instead of 10, if you are giving any other number. On PPT, for the same range, I have given the step size equal to 3. So the respective result is like this. First value is 1. Next value will be 1 plus 3, that is 4, and so on. After that, you can check if you are not giving any step size, if you are not mentioning the step size, only the start, only 2 figures if you are giving, then first value will be taken as starting value, second value is an end value, and by default step size equal to 1 will be considered. Right? So if you are not mentioning the step size, default step size will be 1. For the same purpose, another instruction, line space. But here we can mention there how many values we need. Equally spaced, how many elements we need. Suppose I want 50 number of elements in the range 1 to 10. Then I have to use this type of the instruction, line space, right? So see here, z variable is equal to line space 1 comma 5 comma 9. So first value xi is giving the first element, xf second value is mentioning the last element, and the third value is mentioning the number of elements, how many number of elements we want to generate. So we will try this. So you can see within the range 1 to 5, within the range 1 to 5, total 9 values are generated. Equally spaced values are generated. You can change this n figure as 20. So you will see total 20 number of values are generated, and all the values are equidistant. You can check it. Values are equidistant. After that, you can try. If you are not mentioning the n value, then what happens? Give only the 2 parameters in bracket. Don't mention third value and see what happens. Yes. What is the result? If the third parameter, that is the number of elements, is not mentioned, then how many elements are generated? Here you can see 100. Total number of elements generated are 100. I can check it by size function also. Size, whatever the name I have mentioned over there, that is Z1. Size of Z1. It is containing one row, 100 columns. That means 100 number of elements are generated. So default value, if you are not mentioning the size, then default value is taken as 100. Okay. Everyone see the spelling? It is Linspace. Another thing, if I want to know in detail about this particular instruction, right? So what I will do in that case, help Linspace. Sorry, spelling mistake. You can check here. If I am typing here help and the function for which I want to see the help. So everything in detail about that function is displayed over here. What is the syntax we should follow? And here also you can see also, that means similar instructions. If any another similar instructions is available, then these are also displayed here. You can click on that to see the detail about that particular instruction. And see below, these two lines are given as documentation for line space. Means if you are clicking on this, you will get the file which is opened in another window, in separate window. There you will see some examples also in which that particular function is used. See here, for example, this line space function. Syntax is given, description is given, and some examples also we will see. In these examples, that particular function is used, right? And the respective output, everything is given in detail. So if you want to know more about any particular function, then what we have to do is on command prompt, type help space that particular function and then enter. At the bottom, you will see here documentation for line space. If you are clicking on that, then another file will be opened in new window, which is giving some examples also in which that particular function is used. So it is very helpful. Now, some restrictions about variable. Now we are declaring the variable to save some values, right? Variable in Matlab is a symbol used to contain a value. Then while deciding the variable name, we have to follow this. Variable names must begin with a letter and its length, it must contain less than 32 characters. I cannot give the variable name which is containing which is having length above that 32 characters, and that name should contain only letters, digits and underscore. Only these things are allowed: letters, digits and underscore. Okay. Another restriction or another fact about the variable is Matlab is case sensitive. The following names represent different variables. You can see the speed word is mentioned in different form. So all these three are representing different variable because here only the one letter is kept capital. Here all the letters are capital. So everything is representing different variable as Matlab is case sensitive. So these things we have to keep in mind while giving the variable name. Maximum length 32. Only letters, digits and underscore are allowed, and it is case sensitive. Means small a variable is different than capital A. We will see how to type a code in that editor window, how to write a script. So in Matlab, the different operations, whatever we are performing, this can be done in two different ways. First thing is by using Matlab command window, as like whatever we have discussed just now, using Matlab command window. And another way is using editor, that is .m file. So simplest type of Matlab program is called as script. A script is a file with .m extension. As I have shown you previously in that current directory, all the program files are stored with the .m extension. And that .m files can contain multiple sequential lines of Matlab commands and function calls also. We can run a script by typing its name at the command line. So we can make one program and we can run it as an example. So what is the advantage of using editor window is that means instead of typing the code on command prompt, if we are using the editor window, what is the basic advantage is that on command prompt, we have to run the code line by line, one by one line we have to execute on command prompt. But if we are using editor window, the whole program at a time we can execute, whatever is the length of that code. Okay. So to use one new script, we have to click on File, New and Script. That also I will show you in demonstration. Here is our Matlab online window. If I want to clear all the contents of command window, I will type CLC. Now, if I want the new editor window, then what I have to do is press over here plus sign new script. You will get a new script here, which is having no any title. It is labeled as untitled, right? So we have to apply some name afterwards. So here, any small program you can write, whatever the things we have discussed just now. Out of that, anything you can type over there. A is equal to suppose 1, 2, 3, 4. Then S is equal to A 1, 3. And save this. When you will press save, it will ask for the name. Give any name, whatever you want. But while allotting the name, it should not be a function name. That care we have to take. For example, line space is a already inbuilt function available in Matlab. So we cannot give the name, file name as a line space. Suppose AA I have given. So that file is saved as aa.m. If your current directory is visible, you can check that file in current directory. Okay. Now we will discuss how to plot the values. Okay. Line by line we will see. In Matlab, if you want to add some comment for your better understanding, we can use this symbol so that that line will become unexecutable. It will act as a comment. Since we are trying to plot some values, the comment is given as plot. Then always we will give these common instructions in every Matlab program. CLC, you know the function of CLC, what it does? It clears the contents of command window. It will clear the command window at every execution. Clear instruction will clear the values of all the variables, right? So because of previous execution, whatever are the values stored in the variables, this will be cleared. Then this instruction also already we have checked separately. X is equal to, in square brackets, some values are given. Means here one vector X is created, another vector Y is created. So in your editor window, you try to give these commands. In the editor window on your online version, give these commands, add any comment, then give the CLC, clear, you can say clear all also. Window, give these commands. CLC, clear all, common instructions, and then whatever is your code. First, we have declared the X variable, Y variable, and then we will try to plot these values, X versus Y. So there is a plot function, inbuilt function in Matlab. So your next line will be plot in round bracket X comma Y. Plot in round bracket X comma Y. Okay. Since we have done changes here, I have to save it. Press on save function. In your case, it will ask for name or file name. Give some file name with .m extension is there already. Okay. Then we have to execute it. To run it, here can you see this triangle button which is labeled as run? Press on that, run. Yes. Instead of plot, I will comment that plot instruction and I will use stem instruction. Stem of X versus Y. Save the changes and run it and see the result. So what is the change observed? So X values means X axis is giving these values. Y axis means amplitude values are here. So at the 0 location, amplitude is 0. At the location 2, amplitude is 4. You can see here at the location 2, amplitude is 4. Location 4, amplitude 2. So this way the values are plotted. So previous plot was continuous and now this plot is discrete. Only the sample at that particular location is plotted. Okay, done with this, everyone. So individually, two figures I have observed, but if I want to observe the result simultaneously, then what I have to do is okay. So can you see this, whatever I have done? So if I want to see both the outputs parallelly, then what I will do, I will split that figure window in two parts, right? So in two parts means you can see in terms of rows and columns. Here, a single row is there, but two columns are there. So accordingly, I have to give these values of row and column in the subplot instruction. Subplot is the inbuilt function I'm using to split the screen.
Hold on.
Okay, so subplot in the round bracket, first value I will give for the number of rows, comma, second value will be mentioning the number of columns, right? So 1 comma 2 means what? The figure window I am going to split in the format one column, one row and two columns, right? And that's why I'm getting two sections, two subsections. Out of that, first subsection I have to use. That's why third parameter is comma 1. Third parameter is given as comma 1. So in that subsection, first subsection, I'm going to use the plot instruction. Then subplot 1 comma 2 means second section, subsection. There I'm going to use the stem instruction. Means in plot function, the points are connected continuously, and in stem, the points are connected in discrete way. Means only the samples I am observing. So this is mainly required when we are dealing with digital type of the signals. So you understood what I said about this splitting of the figure window. I repeat this. I want to observe both the outputs simultaneously. So I will split the figure window in number of subsections. Suppose here I want only two sections, and in this format means one row and two columns, right? So in subplot instruction, in the round bracket, I will give the parameters like 1 comma 2 means one first parameter is for row, second parameter is for column, and the third parameter is to indicate out of all the subsections which section you are going to use. So first one I am going to use, and there I am using plot function, means continuous graph I will get over there. And in the second section I am using stem, means discrete function, discrete graph I am getting in the second subsection. So everyone try this subplot instruction. So instead of observing single figure window, single output, I can observe here both parallelly. So see, instead of giving same x comma y, I have added some more parameters. Save the changes and run it to observe the effect. See here. So what are the changes we are observing in second graph? X and y parameters are plotted, but the color is different. Now the water color used is different. It's blue because of the B parameter given here. B indicates blue color. Along with that color, I have given the dash also, dash and dot. If you can see, dash dot. That's why the style used to plot the line is dash and dot. Along with that, star is also mentioned there. So it is used to indicate this peak points. Amplitude level is denoted by that star mark. So this way we can add some more features in plot function. You can also try in your code, make the changes, save it, and then execute, then run it. If completed, tell me, acknowledge me. Previously, whatever stem function you have used, in that add these parameters also. Color, style of the line. So whatever are the different options available, that also we will see afterwards. How to see that? What are the different options available? What to do for that? I have to see the help. Help will give me all the information. Help space whatever the function for which we are trying to see the help. Okay, so then only this x and y variable line I have kept like that only, and I am making another modifications. Here you can see you don't have to apply the comment for means line by line. You can select all the lines here, and by right clicking there is an option comment or uncomment. So this part of the code you can see subplot 1, 2, 1, and there we are using stem. In this subplot 1, 2, 2, that means in second section we are using plot. But along with that, some additional instructions also are there. Save the changes and run it. X label and Y label I have added in the second section only, means subplot 1, 2, 2. So for that particular graph, title as well as X label and Y label has been added. Here the spelling for X label is BEL. By mistake many times we are giving it as BLE. Whatever the title we want, that we have to give in single quote, round bracket, single quote. Okay, are you getting this output? Title, label, this way we can add to the graph. Four subsections. Figure window should get divided in 4 subsections. Out of that, first one I am using for this particular instruction, stem x, y with this other parameters. Second section is used again for stem, but I have used this instead of B, I'm using R, and this star is also changed by some other notation, some other symbol. In third section, some more parameters I have added, and the fourth section I'm using plot. So we will execute this and we will see the corresponding result. Save the changes. Quit and run it. First of all, you'll see the effect in output and then you will try at your end. So in the first subsection, plot between x and y only. Everywhere we have used the same values, just slight parameters we are changing. In the first plot, first section, blue color along with the star mark for marking of the points. In the second section, red color is used. The style of the line is dash dot is used, and the marker is changed. Marker shape is changed. Its circle is used over there. In the third section, you can see it's a continuous graph. Continuously points are joined. These points are joined continuously as the function used is plot. The color is different. So for that magenta color, M is a notation, right? And this D is used to show the markers. D for diamond. Diamond shape is used to mark the points, right? And the dash line style is also changed. If you are observing the previous line style, it is only dashed. Line width is also I have changed. Comparatively, you can see the line width is thick for this particular graph. So we can mention the line width also. In the fourth section, K parameter is used to change the color as black, and the line style is also changed, and the marker used is also different, right? So you try at your end if you want. If you want, copy paste you can do over there and just modify the parameters. Everyone try this at your end. In this splitting, whatever is displaying now, 2 rows are there and 2 columns are there. This way, total 4 subsections we can get. So that's why the dimension given for subplot is 2,2. And since total 4 sections are there, for every subsection, you have to write down the code. And here the subsection, every time I have changed. By mistake, you may override the graph. If I am putting 2,2,1 and then this instruction, then whatever previously I have plotted in the subsection 1, that will get override. So this third parameter, accordingly, we have to change. Is mentioning the rows, second value mentioning the columns. And third parameter is to identify the subsection. Okay, if you have done with this, acknowledge. New figure window. Yes.
Explain the subplot. Explain the subplot again.
Yeah. Suppose this is our figure window. But if I want to observe parallelly number of outputs, then I have to split this figure window in certain subsections. If I'm splitting it like this, then I will get 2 subsections, right? I will get 2 subsections. So what is the dimension? There is a single row and 2 columns I have formed. So in subplot, in the round bracket, while mentioning the parameters, I have to give subplot in the round bracket 1, 2. Means 1 row and 2 columns, right? Comma, third parameter, if I am giving 1, that means this first section will be used. This section, these subsections are counted like this. First, this will be second. If I am splitting the figure, main figure window like this in 4 sections, then the parameter in bracket I have to give like this, 2, 2. Means the figure window is splitted in 2 rows and 2 columns. So which is forming total 4 sections, right? So one by one, while mentioning the third parameter, which is indicating subsection, I will give that value. Number 1 means first section will be used, first subsection. This is the second subsection, third one, and this is fourth one. In this sequence, the subsection numbering is considered. Okay, line width. You understood now? Clear it is? For line width, this way you have to give the line width. Is it visible? Line number 32, you can see. Line number 32.
Ma'am, same syntax I have used, capital L and capital error.
What is the error?
Ma'am, it is written invalid expression. Check for missing multiplication operator.
No. Single quote, have you given? Single quote.
Yes, ma'am. Single quote x comma y comma m minus d comma line width
एक minute. I will put it in chat box. I will put it. You try that same one. एक minute. So here, if you scroll down, you can see all the options for color, pointers, line style. Similar to plot, means parallel to plot function, different options available. You can see in this. See also all the means whole list of all the functions related to plot are mentioned here. Still error is there?
मैम आप प्रोसेस कीजिए, मैं फिर इसका
You can see previous figure is also available. Previous figure is available and new figure window is generated to get the different output means with respect to whatever the newly added lines. Right? So this surf is a function for 3D plotting. So 3D plot, all the things are going to be covered in further sessions. Just to show the new figure window creation. वाढवत जाल ना तेवढा मग ते विंडो साइज छोटी होत जाईल. त्याच्यामध्ये तुमचा प्लॉट constraint. I don't think.
Yeah.
Okay, dependent on the number of rows
Visibility
and columns,
of
right?
graph. Yeah.
Your plot will not be visible. Plot will not be visible properly because every plot will get the very restricted area. Because same size is we are subdividing, no, this many sections. Okay, now how to add the grid lines in a plot? You can add the grid lines in plot. In this plot, we can see at the background there are the grids available. Because of this instruction, at line number 9, grid on is added. See the code completely. This previous declaration of X and Y, along with that plot and grid, these two things are given. So along with the plot, we are getting the grid at the background. You can try this grid function. Here, figure function. This is creating a new figure window, new graph figure. Plot XY, it is drawing a graph. Title, in single quote, we are giving a whatever the title we need. It defines a title for your graph. X label, Y label, define X-axis and Y-axis title. Grid, setting grid lines at graph. Stem is used to show the discrete sequence of your whatever is the amplitude mentioned. It will be displayed in a discrete form. Mesh function, this is plotting the graph in 3 dimensions. Next point is help and documentation. So in between we have seen how to check the help of particular function. On command prompt we will type help and the respective function for which we need the help. And at the end of that we have seen the documentation file. Means there we can observe the examples in which that particular function is used. You can see here help plot. At the bottom of this documentation for plot, click on that. We will see certain examples in which plot function is used along with the syntax here. Here, one example how to use the plot function is given from here also in the documentation for that particular function. Sir, I think we can conclude here now.